Okay, class. We've talked about the oxygen dissociation curve. Now we want to discuss shifting the curve. Certain factors like pH, temperature change, something called 2,3 BPG, can shift the curve. All right. So let's first of all get an understanding of a curve shift in the math aspect. All right. A curve could do a slope change. So here's one slope, that's another one. Okay. If a curve does a slope change, then what will happen? Most x values will have a new y value, except at the pivot point, except at the intersect pivot point. Okay, let's compare and contrast it to a shift in a curve. If a curve shifts one way or the other, each x value has a new y value. Okay, so I'm saying the oxygen dissociation curve can shift. It can shift to the right or it could shift to the left. All right. Now, we want to look at that. All right. Now, this is how we want to examine this. I'm going to come here, and if I can, I'm going to pick what we call the P50 value. I want to explain the significance of this. So I want to pick the P50 value. All right. I'm going to come back here. Now, the P50 value is where hemoglobin is 50% saturated. 50% saturated. All right. Let's assume this curve right here is the normal curve, which will be this one. Let's assume that this curve right here is the normal, and these dotted ones are shifted ones. And these dotted ones are shifted ones. Okay? Now, this is how I want you to look at this. We're picking the 50% saturation. All right. We're looking mainly, I'm going to look at it from the unloading. Let's say we shift the curve this way to the right. We shift it to the right. All right. Now, what that will mean is, and we're looking at the unloading. Now, let's look at this. What this means, and I'm starting with the regular curve, is that when the oxygen tension around a hemoglobin molecule, let me say that, when the oxygen partial pressure around a hemoglobin molecule gets to 27, when the partial pressure around a hemoglobin molecule gets to a value of 27 millimeters of mercury pressure, that hemoglobin will drop off 2 O2s. Let me say it again. 50%. When the partial pressure around a hemoglobin molecule gets to 27, that hemoglobin molecule will unload 2. See, normally it wouldn't do that because normally you would never get to 27. Normally you would stay at 40. Remember we talked about that. Normally in the tissues you'd stay at 40 in the tissues. Now in the cell 23, but in the tissues, because you see the tissues first, the interstitial fluid. So normally the utilization coefficient is just knocking off 1. But let's theoretically say that you got down to a 27. If you got down to a 27, then what it's saying is that it would unload half of them because it's trying to bring you back up to what you should be. It's trying to bring you back up to what you should be. Okay? So at a 27, it would unload 2, 50% of the 4. Now, let's say though, if the curve shifted for some reason, we'll talk about it. So this is a shift to the right. That even if you had a 40, you'd drop off 2. Even if you had a 40, you would drop off 2. Now let's do this. Let's see if I can explain this. Okay. 3 guys are very rich and they come to you. They say, how much do you have in your bank account? You say, well, I've got $3,000. They say, well, we're going to be liberal. If you get down, one guy says, if your account gets down to 2,500, I'll give you the 500 back. I won't do anything until it gets 500 down. One of the other guys says, if your account gets down to 2,700, I'll give you the 300 back. So I'm not going to wait till it gets to 2,500. And then another one says, if your account just gets to 2,900, I'll give you $100. Who's the most liberal? All of them are rich. The one that says, if you just get down to 2,900, I'll give it to you. He's more willing to lose. He's more willing to go ahead and give you the money. So let me put it back in this. He's easier to let his money go. The one that'll just get you to 2,900. So if you shift over this way, this is what we're really saying. A right shift decreases the affinity. Affinity means drawing power. A right shift decreases the affinity of hemoglobin for O2. Let me say it again. A right shift decreases the affinity of hemoglobin for O2. Hemoglobin is more liberal in its liberation of O2. Because what it's saying is you don't have to get to a 27. Even if you're at a 40, I'm willing to unload 2. Even if you're at a 40, I'm willing. See, normally at a 40, you'd unload 1. But in this case, if the curve shifts this way, it's saying even at a 40. So a right shift of the curve means the affinity of hemoglobin for O2 is less. Now, that means then that a left shift means it's more affinity, because look what it's saying. You got to get down to a 10 before I'm willing to let 2 go. So a left shift increases the hold of hemoglobin on O2, and a right shift decreases it. Okay? Now, let's see what would make that happen. Okay, let's see what would make that happen. If the curve shifts to the right, and a right shift of the curve is called a Bohr shift. Listen to me. From the guy named, that was Niels Bohr. Niels Bohr was, he was the father of Niels Bohr, Christian Bohr. He's a physiologist. Niels Bohr, which did a lot in chemistry, the Bohr model of the atom. These guys here, dad and father and son, are very famous. But a Bohr shift is a right shift. It means hemoglobin has a decreased affinity. It will unload easier. The left is the opposite. Okay? Now, what would cause a right shift? What would cause this to happen? An increased temperature. Now let's think about it. If you have increased temperature, your metabolic rate goes up. If your metabolic rate goes up, then you're going to need more oxygen. If acidic conditions can do it too. Acidic blood would unload to the right. And we'll talk about that. But acidity, a lower pH, will cause it. See, a lower pH, CO2, carbon dioxide, when we get to carbon, creates acid. If you have increased CO2, because CO2 is being made in the mitochondria, but you need oxygen to do it. The mitochondria, that's a byproduct. So that increased acidity means a whole lot of CO2, which theoretically means you need more O2 because you're burning the stuff fast. Okay? An increased 2,3-DPG. 2,3-DPG is basically this, that when you're doing glycolysis, okay, and you're going to go into the Krebs cycle, basically you can't get into the Krebs cycle unless you have O2. You cannot get into the Krebs cycle unless you have O2. So when you're doing glycolysis, you normally make this 1,3-diphosphoglyceric acid. I'm just showing you something. And then that would be fine, and you'd go on down and have enough oxygen, get into this. But if for some reason you start going down and you can't get into the mitochondria, why? Because there's not enough oxygen. You can't form the acetyl-CoA, we'll say. It's not enough oxygen. What do you need to do? Then you're going to start building up lactic acid, first of all. So this pyruvate here, okay. So an enzyme in the body, which normally doesn't work unless the concentration of this gets high, will kick it over to 2,3-BPG. 2,3, which is biphosphoglycerate, that 2,3-BPG sits on the same spot as oxygen. So what does that mean? Two people competing for the same chair. That 2,3-BPG then would kick the oxygen off. Now, if the oxygen gets kicked off, what happens? Then pyruvic acid then can go ahead, okay, and become acetyl-CoA because the mitochondria now can accept it. So things that would do the right shift again are that. Things that would do it are this. Less affinity, increased PaCO2. So here's the things that could right shift. Increase partial pressure of CO2. Increase in 2,3-BPG. B and D are the same thing. B is biphosphoglycerate. The old name was DPG. You have I don't know how many of you know this, you have something called the IUPAC, the International Union of Pure and Applied Chemists. It's a worldwide organization, and they give names. The old name was di, and then they went to bi. So that's what you'll see. An increase in acidity, right shift. An increase in temperature, right shift. What about a left shift? This way. A decrease, the exact opposite. Decrease in this, exact opposite. Decrease in this, decrease in temp. You see what I'm saying? So that's what does it. That's what does it, to do these shifts. Okay? So let's go down here. So this would be a guy, let's say, factors, more acidity. He's exercising, making more lactic acid. Shift this way. What do you need? More O2, right? Increase temperature. Increase metabolic rate. You're going to need more O2. Increase CO2. Partial pressure CO2. You're making more CO2, which would give you more acidity. And then this here. That right shift is called the Bohr shift. That right shift is called the Bohr shift. All right. So we've talked about that. Okay, now I'm going to go a little further. Now I want to, and see, here's the thing. Here's the temperature. Decrease temp, left, increase this way. Carbon dioxide, same thing. Decrease this way, increase that way. Okay, here's my talk on the 2,3-BPG thing. All right. So we go further then, and my questions come, where would you position a fetal hemoglobin curve? To the right or to the left of the adult curve? All right. Now, remember, the fetus has to pick up oxygen from the mother's blood. The fetus has to pick up oxygen from the mom's blood, right? So if we think about that, okay, if we think about that, then let's see if I can find something here. If we think about that, then we can say, I thought I had something. We can say then that the mom's blood would have to give it up to the kid's blood, right? So then the mom's curve would have to be over here. Why? Because it has to have more affinity than the mother. It has to pull it off the mother's. Now here's myoglobin. Remember the red stuff in muscle. Here's myoglobin, the red stuff in muscle. Where's it going to have to get it from? From your bloodstream. That means that curve would have to have more affinity than the usual. See, here's that myoglobin right there. So in other words, anything to the left of the normal curve has a greater affinity. Anything to the right has less affinity. Okay? So that kind of explains this curve to you. You can study on it. You can study on it, but that kind of explains that. And then you can read through my PowerPoints. Okay? Hopefully that gives you a pretty good idea of what I'm talking about. There's some more stuff, but you can read that. All right. Thank you.